And now let's dive into the gearbox assembly. So the gearbox assembly here, let's see if we can get this other cover off. A little bit of grease in there. The entire assembly is threaded together. So there's a threaded tube here and then a threaded body here, and they're spun into each other. So I'm going to go put it in the vise and try and spin it apart. Hopefully we can get it out. Alright, so they had this Loctited because it's not meant to come apart for service. So once we got the Loctite broke loose, we can spin off this housing. And this is just a threaded tube, right? It's got a seal in the end, got threads on the other end, so we'll set that off to the side. Now we get into the interesting part. So we've got this chrome steel shaft that rides against that seal surface, and as we spin it, you can see there's a screw down inside. Now this style screw, it looks like it's actually a ball screw, which is a precise type of screw that's used in motion equipment like lathes, where you need precision movement. And as we get this apart, I would not be surprised at all if we start to get little tiny ball bearings falling out of it. But what happens is when the motor drives it, the worm gear rotates this ball screw, and that screw then moves the shaft in and out of its housing. Let's keep going here and see how far apart we can get it. I think we just hit the limit of our travel. So looking at the way this is put together, we've got 3 of these little engagement pieces. Let's see if we can pop those out and see what's going on there. So as I'm scratching around on them here, they feel like steel pins, and they feel pretty hard. So it might be tough to get them out of there. I don't see any way to drive them from the other direction. They don't look like they spin. I don't necessarily want to cut it yet, but I might just do that. I might take a die grinder and cut back through this back piece. But before I do that, I'm going to try and spin this entire assembly apart in the vise. Alright, I really didn't want to come apart. So in order to go further with it here, I put it into a metal cutting bandsaw. And we cut through the actual cylinder part of the tube, so we can see how the retainer on the end of this ball screw is set up. So there's our retainer. So let's see what's holding this thing together. Before I went to this extreme, I tried grinding a flat onto this base and cranking it apart, because it looks like the way that these pins are offset, these holes, it looks like it was probably put together with some kind of spanner, like these pieces thread together maybe, but I can't get enough grip on it to really put force into it. So it was easier to just cut the cylinder tube and get it apart. So it looks like a hex drive, looks like an Allen key. Let's see if we can get that out. maybe the 4.5. There we go. So it is a hex or Allen. Now the trick is going to be to hold it to put enough torque on it and get that fastener out. I'm going to clamp it back in the vise again. Be right back. So I'm not able to get this out yet, but I think it's probably got Loctite on it, and I'm going to heat this end up, then try and get it out. Alright, so in order to get this thing apart, I had to heat it to a dull cherry. You can see the discoloration on it, and there's some grease trapped in there, so when I popped this loose, when I finally got it to break, it shot out grease, which immediately turned into ash, and that's that kind of white coating. But it is extremely hot, so we're going to be really careful with it here for a minute. So you can see the fastener coming out there. Got extremely hot. Some Loctites, some thread locks, you have to get hot like that in order for them to release. There are some that will only release with heat. Alright, so let's put that in here where it can't cause any damage, because it is extremely hot. And now, let's try and get this ball screw off and see if we did any damage to the screw assembly getting this disassembled. Alright, now there's the good stuff. So down inside there, you can see a number of small ball bearings, and it's called a recirculating ball screw because as those balls move around on this shaft, they spin around inside this housing and they recirculate back and forth. So it's a very precise type of motion control. You have very, very little play or lash or backlash in this assembly, almost none. And if you measure precise enough, you can get it to the point where it's effectively none. It's so small that it makes no difference. But that's called a recirculating ball screw. That's what I wanted to show you. Let's see real quick here if we can figure out how this was put together. And I'm sure you'll hear those fall out as the grease softens here, because there is some heat transferred into this after pulling it off the screw. I'm looking down inside there, and I think this, I don't know if this was a friction weld, I don't know how they did this, but however this is put together, it does not look like it will come apart easily. It may actually have just been one single piece that they then came back and ground this outer surface. The more I look at it, the more I think it might be what they did. But it's really hard to tell at this point. I could probably cut it once more, somewhere back in here, and see if it's continuous metal or if it's threaded. Oh, no, there is a thread in there. There's a very, very small thread down inside here. You can just barely see it. So it does thread together, but I just didn't have enough force to get it apart. So the pin drive here would hold this back piece, the pin here would hold this front piece, and the two thread together. Alright, so let's work now on the back of this and get the very last piece of it apart back here in the back. So we've got this big washer. Let's get that out of there. That's a really heavy washer. And then there's a bearing. there's no way to get in the back here on this particular housing. So this whole assembly must just be a press fit, because I don't see any kind of circlips or rings down inside. So at the risk of destroying the ball screw here, I'm actually going to clamp on this ball screw and try and tap the housing off and see if we can get the entire bearing assembly to just slide out. So it actually took almost no force at all. Clamped on the screw, tapped on the housing, and it just popped right out. So it looks like the bearing's actually retained by the washer and the tension of this housing screwed in against it. Now the screw is still kind of warm here, but let's clean up the back. You can see the other end of that worm gear system that we saw earlier. Let's get some of that grease out of there. Now this is pretty cool. It's one of the marvels of modern manufacturing. So this gear interfaces to this gear. And the precision of the teeth is such that as this gear turns and it meshes in against that other gear, the driven gear, we take rotary motion in this direction, where the shaft is rotating like this, and we turn it into rotary motion in this direction with a reduction. So depending on the pitch of this gear, which is the distance between the teeth, which basically forms a ramp, an angle, and the spacing of the teeth on this gear, we get a reduction. And the precision fit on these is tight enough that we can do motion control with it. So it's really a neat system. So when you look at how this is manufactured, they've now pinned this little gear with a nut. So the nut is pinned against and compresses the gear so that this assembly doesn't really slip. It's also interesting that this is made out of nylon or some kind of plastic composite. Almost looks like a speedometer drive gear on a transmission. Not much else in there. The housing itself is pretty heavy. It's pretty substantial, but not much else in there. There might be a bearing down on the bottom of all that grease, but I'm not going to clean all that out to see. So that's it. That's our linear actuator. There's a lot of precision manufacturing that goes on to build something like this, and it's kind of an incredible part just on that alone. Between the bearings, the ball screw assembly, the worm gear, and the motor itself with the stator, the windings, the magnets, the brushes, lots going on here. But very neat assembly. Thanks again, Stephen, for sending it in. I really appreciate it. So I just couldn't let it go. I had to see how this was put together. And I ground flats in on this ball screw, put it in the vise, got a big pipe wrench, and broke it loose. And the reason I couldn't get it apart earlier is because it had a ton of Loctite on it. Had the green Loctite that you need to release with heat, and I did not heat it up, just broke it loose with mechanical force. So at the end it does thread together. There is a thread cut on the inside of the tube, there is a thread on the outside of the ball screw, and if I had really tried, I could have gotten it apart that way without having to cut the entire thing apart. But now we know. So now that we can see down inside there, it actually looks like they've got a piece of a spring inside. And that's because they do. What they've done here is used a piece of wire as a ball retainer, and it's threaded down in to capture those balls and prevent them from coming all the way out the end when it's moving the actuator up and down. So now you can see down inside, you can get an idea of the complexity of that shape. It's a lot of precision machining to get down inside a small diameter like that and create a very precise bore with a spiral like that. So it's a really impressive little piece of engineering. And these caps on the end look like what they actually are doing is acting as plugs. It looks like maybe that's where they fed the balls into the screw assembly when they were putting it together. But that's it. Really interesting little piece of industrial technology. All right, thanks for watching. Hi folks, my name is Jack Kell and I'm a Senior Technical Trainer for Smartcare. The video you've just watched is part of a larger series of technical training videos we make available to our technicians at Smartcare. If you found this interesting and you'd like to see more, please subscribe. I'll be releasing a new component teardown video every Tuesday in 2022. If you're already a Smartcare technician and you have a part that you'd like to see me tear down, please reach out to me internally for shipping instructions. If you're not a Smartcare technician, but you or someone you know would like to learn more about a career as a service technician specializing in commercial restaurant equipment, please check out our open positions at www.smartcaresolutions.com/careers. Thanks for watching.